Hello everyone. Today we're going to continue basics of integration part 2. We will learn more formulas. We're going to learn this formula. So in the previous class we learned power rule and rule of 1 over x or x to the negative 1. And just when you solve this, what can remind you that when you solve this power rule, generally it's quite easy, but you need to be careful when solving roots, because roots need to be changed to exponents, and also you need to review how to add and subtract fractions. That can be tricky, this basic algebra. Okay, so now let's solve this example based on to practice this formula. Okay, so we have integral. First is 4ex. 4ex will be 4 to the power of ex. We are using the first formula. The next one will be plus 2 times 3 to x over ln 3, natural logarithm 3. We use this formula. Then we're gonna have minus 6 cosine x. Why is that? Because in this formula you see sinus changes to negative cosinus. We just multiply it by constant. Constant remains the same, so we have 6. And you had plus, so it has to change to minus. Then you add plus 5 sinus x. We use that formula. This formula, cosinus changes to sinus. Then we have plus 7 over, no, not 7 over, but you get 7 arctangent, 7 arctangent x according to this formula. Because in the denominator we have 1 plus x squared. So when you have 1 plus x squared, it means you change it to arctan. It's not only 1 over 1 plus x squared, it can be any number, just like here was 3 over x, 5 over x. So here if we have any number over 1 plus x squared, then it gives arctangent x and plus 3 arcsinus x according to this formula below. Plus c, of course, plus constant, and integral is solved. This is very easy integral because we just plug the formula directly. We don't need to do any algebraic changes or mathematical modifications. But it may not be so easy. As you can see, it is often necessary to perform algebraic manipulations. It's just like these examples below. For example, you need to know some algebraic properties. Somebody said once calculus isn't hard because of calculus, it's hard because of algebra. So you need to know algebra first, then you can do calculus. Without it, you won't be able to do it. First example applies algebraic identity or property difference of squares. So you can see that this expression was rewritten as that one in the numerator in order to get rid of this denominator. So now we can simplify. 1 plus x will be cancelled out, it will be 1, but 1 is irrelevant here, so you will only have an integral from 1 minus square root x, which will be x, because integral from constant gives x, from number changes to x. For example, 2, it gives 2x, 3 gives 3x, then you minus x to the power of a half, because that's how we convert roots to exponents. Then it will be very easy. It's gonna be x minus x to the power of 3 seconds or 3/2 over 3/2. Then it will be x minus 2/3. We can just change this. X is it remains the same, so we don't need to focus on this. Let's focus on this long fraction. So it's going to be 2/3 x to the powers of 3/2 or 3 seconds. Why like that? Because Dividing is multiplying by reciprocal, so 3/2 become 2/3. And this is the answer. So now let's solve this one. This one is quite difficult, right? Because x to the power of 4 becomes this very long expression, long polynomial. But what you see here is exactly, it means x to the power of 4. So you need to practice this method. And other examples I encourage you. So this can help you simplify the denominator. But when you solve this kind of example, you should know that you cannot just simplify this expression x squared plus 1 only once with this and continue, because you see there is minus and plus. With the rule of fraction, it means if you have a plus b, or for example minus c, and over something, if you simplify the fraction like that, if you split, when not simplify, when you split or divide into 3 parts, this part will be, for example, x will be for every part here. If you had x here, this x has to be for every part, because what it comes next, in order to perform this subtraction and addition, you need to split this fraction. So let me erase this first, and now when you understand what we're doing here, we can proceed further. So what you're doing here is gonna be x squared in the brackets x squared plus 1 over x squared plus 1. Then you have minus x squared plus 1 over x squared plus 1. So this will simplify it. You have x squared left, that will be equal to 1, so you ignore it. Then you have minus 1, and you will have plus 1 over x squared plus 1. Okay, then you can continue, and you will use the power rule. Now you can use the power rule, and later you see that you have x squared plus 1, so this will become arctangent based on this formula here. You have arctangent 1 over 1 plus x squared. So the final answer will be, you can check it yourself, 1/3 x to the power of 3 minus x, because you had minus 1 becomes x, and plus arc tangent x plus c. But you see, we couldn't just apply this formula directly from this. You had to do some algebraic manipulation. Then it becomes simple. You can use power rule, you can use arctangent rule. Okay. And another one is the last one here. Let's do it together. So I just erase it here. You can save on the screen what we did here. So we just solve this with cosine 2x. For this example, we're going to use identity for cosine. So cosine 2x equals cosine squared x minus sinus squared x. That's why this cosine 2x becomes cosine 2x minus sine squared. We can rewrite it, and thanks to this modification, we can simplify it. We can now simplify later, because this can be changed. We can again use difference of square here. We will do difference of square, so we will have something like cosine x minus sine x in brackets, and here will be cosine x plus sine x. And in the denominator you write cosine x minus sine x. So you will simplify this part, and what you will have left is only cosine x plus sinus x. So it's gonna be easy to apply a direct formula from this point. So you can do it by yourself. Okay, another one is that arctan formulas can be a little bit more complicated, right? This is the basic one. We learned the basic one, 1 over x squared plus 1 changes to arctan x plus c. But what if after x squared you have different numbers? Just like here you have 4, 5, 6. So for this case, like this, you will use this formula, not the first one. You need to apply this formula. It will equal like that. So let's solve it together. So it's gonna be, you just need to see that you have a and you have x. So you need to know what is a, what is x here. So you're gonna write 1 over x. No, you're gonna write 1 over a, which is a is this point. This is a. So a is 4. It really is it 4, but you can see this is a square, so it means that you need to change it to 2. So it will be 1 over 2, because a equals 2. A doesn't equal 4 because it's for a squared. We can see that a squared equals 4. That's why a equals 2. Then, so using this formula, we write 1 over 2, a 1 over a, which is 2, a half arctan x over 2 again. And this is solution. X over 2. This is our solution. It was quite easy, but there may be a case that is more difficult, just like here. As you can see, we don't just have a binomial here, we have a trinomial. So in this case, we have 1 over trinomial, 3 terms here. You need to use the method which is called completing the square. This is the formula. How can we complete the square? So soon I will do this to show you. And later, after you simplify it, you will simplify it to this form. You see this form here, and you can apply that formula. So for this case here, case 1, you use this formula. For case 2, you need to use that formula. But before you apply this formula, you need to complete the square, transform this trinomial to simpler form. So first I'll show you how we can complete the square. So in order to complete the square, we need to divide. Here we write x plus 2 x plus 2, we write it in brackets to the power of 2. Then we minus 4 divided by 2. And we also take it to the power of 2. So as you can see, this is term b. Term b is 4x. 4x is b. But you see square. So you take the square, but you divide it by 2 because it has to, according to formula, it has to be divided by 2, and then you add plus 5. So it's gonna be x plus 2 squared, x plus 2 squared minus 2 squared, because 4 divided by 2 is 2, 2 squared is minus 4 plus 5. Therefore, you will have x plus 2 squared. My mouse battery is weak. Plus 1. Okay, I'm not gonna use the mouse. Plus 1. And now we completed the square and we are ready to apply the formula. As you can see, this x squared plus 4x plus 5 became x plus 2 squared plus 1. And from this you can easily, I use this formula here, which you see this formula. So you see what is a, you see that you have p and a, x plus p plus a. So now again we write 1 over a. So 1 over 1, so this one you agree because a equals 1. This is our a, so we don't have to write it, we can just write arctan. Again, I'll try with the mouse. Arctan. This one is 1, so it stays, but we need to continue with this form. So it will be x plus p. P is a 2. So it's going to be x plus 2. And over a, but a equals 1 as we said. So it just, that is already the answer. Arctan x plus 2. We don't need to divide anything because a equals 1. Okay, and we solve this problem. But remember, we had to do method completing the square according to this form. Okay, I have exercise for you. Solve this integral. You can do it yourself. Solve this integral using the arctan formula. I mentioned this arctan formula, but pay attention that here completing the square will be more difficult because leading coefficient is greater than 1. So in order to solve it, you should first divide the quadratic polynomial by a. So all this polynomial, everything you will divide by 2 because a equals 2. And after dividing everything by 2, you will continue with the same calculation as I did here. Finally, I want to tell you something about inner functions. Inner functions. So you can see that 2x in brackets to the power of 3 is different than 2x to the power of 3. This requires different calculation. You can see it here in the box that, for example, without brackets, you just apply power formula. But for this example, you see 2x is an inner function. 2x is an inner function, so it needs to you need to use the derivative, right? So you need to modify the usual integral formula by dividing by the derivative. So here when you write dividing, so you multiply by the derivative, so you increase this denominator by the derivative. So what is the derivative of 2x? Derivative of 2x is 2. That's why we multiply it here by 2. So because it's division, but it's increasing the denominator by the value of derivative of inner function. And the same is for other formulas which we learned today. So for example, to the power of x, you use general formula, but if it's e to the power of 2x, 2x is an inner function, then first you apply this division by the value of derivative. Again is 2 because 2 of derivative of 2x is 2. And also it applies for sine or cosine function. Okay, so this is very important to know that if you see inner function present, use different formula than the original one. Okay, it's just the beginning. We still have a lot to learn. In the next video, we'll talk about integration by substitution and integration by parts. So you can see these two formulas, but it's gonna take a lot of time, so it's good to discuss it in the next video. That's all for today. I hope you learned something. Thank you for your attention.